Yo, what's up, everybody? Welcome back. Today, I want to try to fix my GUI framework and make it possible to render a billion widgets. Right? I think that that's just like a eye-grabbing number. But in reality, this is an actual thing that I want to do. Because my monitor died, so I used to keep Twitch chat on the right side. I no longer can do that. I keep it underneath my camera over here, right? And the Firefox, or like just like the embedded web view, is garbage, right? It's like it doesn't, well, not garbage, it just doesn't really like fit nicely here. Like I have to go into like the inspect element a bunch to like remove a bunch of UI widgets and stuff. And in reality, it's like a good excuse to write a chat client because, you know, we should be doing that, right? And so I want to use this as like an excuse to like stress test our GUI framework. We haven't really worked on that for a while, but kind of one of the longer term goals around here is that I want to kind of write like an entire user space stack. Well, not entire, but like I kind of want to be able to like run Linux on my phone and have all of the software that's being run like be mine. So our GUI framework has a bunch of problems. We can't select text. We can't like right click on stuff and make context menus. We can't the font rendering looks like dog shit, right? There's like all sorts of problems. But in this context, if we try to make a GUI that will render chat messages will come in, and over time, the performance of the GUI framework will just degrade, right? Because the way that our GUI framework works right now is kind of like an immediate mode GUI. So you kind of have like the immediate mode GUI, you know, idea kind of looks like this often, right? You'll have, let's do set file type equals zig or something. You'll have like some function main, and you'll kind of say like, you know, start drawing, end drawing, and you might do something like draw label, and in here you will say like hello, right? And you'll say like then like make a float slider or something with, you know, some floating point number or something, right? And it's really nice because like the rendering of the width of the UI looks very like just like normal code you would write. Our GUI framework kind of like takes some inspiration from this, where the idea of doing layout every frame is kind of cheap, right? Except for in this case where we're rendering a billion rows, but in like the happy path, the layout is cheap. So we say just screw it, layout every frame. However, we do not like the idea that in order for you to have like a float slider, you kind of have to have like per frame state, right? Because if you click on the slider and start dragging it around, you have to know that you're like in a drag on that slider. So immediate mode GUIs are like kind of a lie in that they kind of create hashes of this widget that you've created in this place over this, like in this sequence of events. And then they like store some state a lot beside it sneakily. So what we do is we have something that looks a little bit more like this, where we create a layout. We create like a set of widgets. And so like in this example that we have right now, we have a layout. In that layout, we push a bunch of labels into that layout. We stick a little frame around that thing so it looks kind of nice. And we stick that thing in a scroll view. And then every frame we call step on our UI. And every step we like calculate some bounds. We ask all of the widgets to like yoink the latest state from the application. We handle input. And then we do some rendering, right? Which is not too bad, not too bad. Now, in this case though, it is kind of bad. So in this little example, we have rendered 4,000 labels here, right? 3,999 bottles of beer on the wall, 3,998 bottles of beer on the wall, 3,999 7 bottles of beer on the wall, right? And we've kind of got all these in here. And if we look at the like CPU usage right now, just sitting here doing nothing, we're using 110 CPU. And if we try to do relayout, it's even worse because it has to relayout every single widget in this entire view every frame, right? Which is like a total disaster. So in the context of Twitch chat, messages will be coming in over time, and we will be approaching this case, right? 4,000 is actually in a range of reasonable amounts of messages to happen in a stream, right? I mean, it would be a lot. You guys would have to like be typing like crazy. But if we want to spam "we were here," we might see something get approaching this order of magnitude. And so we need to find some system that doesn't behave like this, right? And so that's the plan for today. So, I was looking at like my signal on my phone, and I was just like looking at the scroll bar as I scrolled around. Because something interesting about layout is that you can't really do layout. Like, how do I say this? Where this 3,864 bottles of beer on the wall starts depends on all of the text before it, right? So you can't really, if you resize, to get like a perfectly accurate representation of this thing, you actually do have to lay out all of the text before it, right? But we can fucking cheat, right? Cheating is cool, okay? We all love cheating around here. And what you can do is you can kind of do the layout in, I don't know what to call this, like item space, right? Where instead of saying at the top of my scroll view is like 5,000 pixels from the top of the view, you can say the top of my screen is in the 4,999th item or something like that, right? Or in this case, we're actually in the 2,505th item if you're scrolling from the bottom. Cheating is cool, Sphero, clipped and shipped. Yeah, cheating is mandatory. So, if you look at the scroll bar on Signal, it will actually like increase and decrease in size depending on the size of the content that you're looking at. So I'm pretty sure they're doing what I want to do, which is you say which item am I in, and then we will only render those items. So that's kind of like step one. Like part one is like scroll in item space, we'll call it. Then we need some way to only render widgets that are present. And that's kind of it. Right now, the way the scroll view works is, we have like this full layout of all of the items in this thing, and that layout is then put into the scroll view. So I think what I want like a list scroll view, right? Where the scroll view is, instead of being like a stupid thing that just takes a layout that has everything kind of normal, it kind of wants to like have some amount of control over the layout and also like a way to activate and deactivate widgets. So like right now, our widget API, our widget API looks something like this. We have only a few functions on every widget. We have render, get size, update, input, set focus, and reset. This is all we have. And so we would like to be able to preserve a way for each of the widgets in this like giant list of things to be an arbitrary widget, I think, with this API, and ideally we don't change this API. Or if we do, we don't change it that much. Right? So the like life cycle of widget is we say like update this widget, handle input on it, render it. Easy peasy. So I think that what we want to do is we probably want some way, if this is kind of like our app, right? This is a little scroll bar in here. We're like kind of in this area right here. We kind of want some way to like purge widgets that are up here, right? Just like completely get rid of them, right? Or widgets that are down here, completely get rid of them. And we kind of just want to only display widgets that like are relevant to this current section of the layout. And these widgets, we want them to be arbitrary widgets, which means that like kind of the only thing that I think we can do here is introduce everyone's favorite programming concept, factories, right? Maybe we do some factory in here where like maybe our scroll view can say to somebody who like manages widgets, he can say, or like manages like state, he can kind of say like get widget 1000, and then he does layout on that, and then he's like, okay, I need more, get widget like 1001. He probably will also have to inform this system that some of these widgets are missing, right? So if this guy is off screen, he might also say like delete widget 999. There's some other mechanism here where we could try having him like have 5 widgets and manage like copy pasting state between them or whatever. But I think that since like these widgets can really be anything, it's kind of up to someone else to get them. The way that like the overall structure of our GUI framework is designed is that like we kind of feed concrete like retrievers of things. So if we have like text, we'll like create a label that just has text injected into it, and if that text can change, it has like a function on it to say like, hey, can you get me the latest one? Which kind of like follows the immediate mode style, right? Where it's kind of like you don't have to inject state into the widgets; it just kind of like auto updates and redraws when it like every frame. It just like repulls state from wherever and gets it. So I think that we like construct widgets that basically resemble like they can just attach whatever getters and setters they want, and then we just nuke them when they're off screen. So that's kind of what I'm thinking. I haven't really thought it all the way through. But let's just start implementing something and we'll kind of see what happens. We'll see what happens. So hold on, we need to check. This was sometime before now. This was kind of like, wait, what did it say there? 11:24. Sorry, my monitor's broken. You have to bear with me. Okay. So let's do something like just make a widget. Right? We'll start by making a widget. So every single one of our widgets needs to implement this thing. So what do? We can say, hey, I am going to be some sort of like scrollable list or something. And in here, he is going to kind of be associated with some form of factory, for lack of a better word. Everyone complain real quick. No factories allowed. Abstract list view widget factory. Yes, thank you. So he's going to store this guy in here. I took a beer. Please update the count. Yeah. Sorry. 999,999,999 bottles of beer left on the wall. Thank you. Yeah, lazy list maybe. I do like that better, right? Because we already have scrollable things. It's just this one we kind of want to lazily fetch, or like dynamic list. We'll just call it scrollable list for now. Fix me. Think about the name. This is like the least important part of this problem, right? And so this guy is going to need to implement some sort of widget system. So he's probably going to look somewhat like the scroll view widget, right? So this guy holds a scroll bar right now who does what? He renders a squircle in some style relative to some offset from the top is kind of what this guy looks like. And probably we just modify that scroll bar state. Yeah, so we like take the content height and we do something like that. Okay. For now, let's just... Do we copy paste this for now? Probably. Let's, well, is it better to copy paste or implement? If we implement from scratch, then we kind of get a feel for the system again. So maybe we do that, because it's been a minute. So we need some sort of implementation of some interface. So we kind of yoink this guy. Let's kind of skip some of the like more or less interesting parts. So, you know, we won't handle null, focus, or reset right now, but we are going to have to handle rendering, update, and we can also skip input for now. It's not really the interesting part yet. GUI, and this guy, this widget is related to the set of actions that the GUI can request from us. Let's do from scratch, proceeds to yank and paste. I mean, a little bit of yank and paste never hurt anybody. A little bit of yank and paste never hurt anybody. So this is render, this is get size, and this is update. Okay. So for now, for rendering, we don't have to do shit. Right? We know that much. Because we have nothing to render yet. This guy is probably going to have a list of like active widgets, right? That sounds right. So he's going to be like, give me a Probably one of these guys. Runtime segmented list of GUI widgets associated with GUI action, which means that, like, I don't know. We'll see. Do these go in order? Maybe. Probably, right? And so if we throw like 5 widgets in here, we're gonna do something like, these guys are gonna need to be like laid out in some way as well, right? So like on update, we don't have like where we're positioned yet, because the idea is that you call update on some label or something. It like determines its size, and then you use that size as part of the next step of layout. So what we have is like the available space here. So when we do update, we're gonna update all of our child widgets. Surely. We need self here. So self is whatever the fuck we are. Which is a pointer cast, a line cast of the context. Can you define a static size of widgets and fetch the data from the real source on scroll? I think I'd rather not. I think. But like, maybe that would work? I'm not sure. We'll fill it out. Okay, so for each widget that we interact with, we do what? We need to call update on it. And each widget has the same available size. Probably you could do something where you like shrink available as widgets give size. In fact, we probably do want to do that. I bet you that's what our layout does. So yeah, he has give me the available size, which takes the cursor state. Right, so every frame, the layout like resets a cursor that's moving top to bottom, and then he says, give me the rest. That makes sense. That makes sense. We can kind of do the same thing. So also we are going to have to check like our scroll state, probably. Can we just render the scroll bar first? Let's kind of like not do any of this stuff, and let's only worry about a scroll bar. Let's only worry about the scroll bar first, because that'll be easier to prove. So this, I think we saw we had a widget in GUI scroll bar height. And how was he used in the existing scroll view? That's the question. So on update, he might choose to present the scroll bar. We will kind of ignore that for now and just always show it. I think that's easier. And he sets the position based off something. On input, surely he does something on the scroll bar. So he has new scroll ratio is based off of handle input. Cool. And then does he do anything with this? He assigns that to his offset. Yeah, okay. Cool. And does he handle like scroll as well? Like if I change the scroll wheel, do I do something there? Consume scroll here. Yes, okay. So let's just ignore most of this for now and just try to do the scroll bar if you click on it directly. So it looks like we are responsible in this thing to store scroll location in item space, right? As we were kind of talking about earlier. We do need to handle input then, huh? So we have this input state function. Let's kind of just do this. And it looks like we need some way to find the scroll area bounds, which is just going to be on like the right side of our widget, probably, right? I bet you that they had something like a little bit more complicated, they being us, right? Probably it's like, if the thing is 0, oh no, he just does this. Okay, we can copy this, that's fine. That's fine by me. So here we have our widget bounds. And the scroll bar. Perfect. Perfect. Yep. And we just shove that shit on the right side, right? So we go right side minus the width for the left. Beautiful. Beautiful. Okay, cool. That's starting to look like something. So I assume this is like widget bounds? Not the input bounds. Yeah, it would be the widget bounds. Then if we have a new scroll ratio, we set scroll offset to be something. So what were they doing there? They were calling content height times scroll location. Oh, because they were storing it in this is like ratio. This is scroll ratio is what we'll call this. So I think this is if let's see, what does this guy talk about here? He's got top offset, which is where the handle is relative to the size of the scroll bar. Okay, sure. So this is going to be like somewhere between 0 and some number less than 1. Okay. And then what did they do in the scroll view? They probably set the ratio after they calculated something. Yeah. So I assume that this handle input doesn't modify it. It just tells us what the new thing would be. And so we have to reassign that ourselves. So technically, we actually can just work with this guy directly. We don't need to duplicate this information. We can kind of just work with what he's storing. We did something different before, but I think that we can just work with this. That seems fine. Okay, so update, we probably do nothing. Well, unless there's a scroll bar update. I don't think so, though. It looks like he only has render, which seems kind of nice. Let's, but we can probably set our size. We need to fill the available space, probably. Probably we, as our scroll view, need to fill up as much space as we can. So let's store a pixel size here, and on update, we just assign this. And then when somebody like above us tries to do layout, we just return self size like this, easy peasy. On render, we literally just want to render the scroll bar. Probably. So is this guy want the bounds of the scroll bar? Surely, right? So we probably want scroll bar bounds of widget bounds with the window bounds as well. And then I think that's kind of most of it. I think that this should be like a usable widget in some way. We probably need to use the input bounds because like the widget can be taking up more space than is available. So I think that or like it could be like covered by other widgets and stuff. So we probably should use this somehow, but I don't know how yet. So maybe they go here, to be honest. That seems likely, to be honest. Scroll, no, because this is the scroll area bounds. I actually don't know. Oh yeah, no. Okay, so we clamp. We probably have to like merge this with the input bounds, which we might just not be doing in the other one. So we have like the intersection of where the scroll bar should be and where input is allowed. It's probably something like that. Something like that. Okay, we need to like have some way to construct this thing. So let's do like what it was called this thing? Scrollable list. So we're gonna have the factory and anything else. We probably need like some sort of like allocator to put this thing on. And this is gonna return a widget? Maybe? Maybe. Something like this. Did Svay manage to render 1 billion widgets or still on step 1? We're still on step 1. Very step 1. We haven't managed to render a single widget yet, really. Okay, so this guy is going to make one of our guys, right? So he's gonna be like, give me the arena allocator. And can we do a little createy of the scrollable list with the factory type that we passed in? Great. And we're gonna initialize this guy. Do we have default values on this or what? How does the scroll bar get initialized? So he needs some squircle renderer and style associated with this thing. So can we pull in the squircle renderer, which is going to be a gooey squircle renderer? Nice. And style, which I think comes from the scroll bar style. I think. So this is going to be like some sort of like gooey scroll bar style. Perfect. And now we can kind of initialize the scroll bar in here. Perfect. This is not actually taking the factory type. This is taking the factory as an any type. Kind of like here. I don't know yet. And then this returns, we get like factory here is type of factory. Boom. Okay, we're getting somewhere. Factory. We're getting somewhere. Scroll bar. He wants the style is style. And he wants the squircle renderer. Boom. And then do we need anything else? I don't know. Then we need to return this thing as like the generic type. So context is the widget, which we've leaked intentionally. We have the name is scrollable list for debugging purposes, and the vtable we can make up right now. So this is actually just scrollable list factory vtable. Boom. Bing, bang, boom. Everyone should be fucking happy, man. So can we make this scrollable list now? So can we just be like, new scroll is a scrollable list that takes in some shit. So we have our GUI alloc. We got our factory, which is void for now. We've got our squircle renderer, which comes from GUI state squircle renderer. Boom. And then we got our scroll style, which comes from GUI state scroll style hype. Easy peasy. So if we've done everything right, we should be able to like have a scroll bar and play with it. He's mad. Because this guy needs to fail when he returns his list sometimes. And then, this guy's mad because... Wait, I don't know what he's mad about. Missing field size on 219. Just kind of give him whatever. We are mad because new scroll... We didn't write try when we made him. He's like, I don't know how to fucking run that shit. So true. Scroll bar doesn't exist in GUI. So true. We got scroll area bounds is not being called correctly. Here, throw a little scroll bar in there. And I think we built. And good news, we have a thing with the scroll bar. It does not look like we are handling input on that thing correctly. And also, the ratio here needs to be updated. So first of all, this is top offset ratio that we're changing. And we need our handle ratio for now. Can we just make this like 0.25 or something? He does not seem to be very happy. Okay, so it looks like the input state stuff isn't running. Probably because we didn't assign that to our vtable, if you think about it. Okay, now he's pissed because this is actually getting compiled. So we, on input, we have nothing that we're doing. We return just like fuck off. Okay, so this is good. This is good. We now have a new thing that has a scroll bar associated with it. I totally didn't get nerd snipe into making this. Wow, yours is way better than mine. Wait, aren't you missing all of the like hundreds shit? Oh, here. Sure. Oh. Oh, I see. You're using numbers. You're using numbers, which solves a lot of the problem, the boring part. I see. Very nice, very nice. Yours is way simpler than mine ended up being. Okay. What am I doing? So now we need this guy to like pull state from the factory, right? So he every frame he wants to kind of check where we are, right? So we have like the scroll bar top offset ratio. This should tell us which widget we're in, right? So index from ratio is going to have to be something like, it's literally just this times something, right? It's like number of items, which is going to come from the factory. So maybe factory is a bad name for this thing, but like num items, right, is kind of what we want here. Who is going to expose itself as a function, because we don't really know how this factory wants to like whole represent its state, so we kind of let him choose, right? And so now we can start kind of making our like beer bottle factory. And he needs a function, num items, who returns a usize, right? And here we will return 4,000 for now, right? Just for now. Right, but or we can maybe construct him with num items here so that it's configurable. Okay. Which means that also we can set the handle ratio based off this as well, right? So we are going to render some amount of objects, and we're going to figure out, I guess, the size of each of those objects. And where we are in the last one will tell us kind of we need to like update scroll bar size from what percentage of widgets are shown on screen. Something like that. After, are we assuming all elements are the same size? We're assuming, so no, we don't want to assume all elements are the same size. I think that we want to do is we want the scroll bar to be an item space, if that makes sense. So the scroll bar will not show the ratio of how many pixels of the full view we have, but it will show the ratio of how many items we have. So I think that will be okay. I think. Factory to brewery? Yeah, right. You're right. That's funnier. Brewery. I do like that better. Okay, so we'll handle this later. But we can at least find our index from here, and that's good enough. So can we say, so we look at the scroll bar tops and we multiply this by num items. So we have num items f is a float from int of the number of items in the factory. Beautiful. And then we can multiply this by the floating point version of that thing. And let's just print this for it. And then we int cast this. No, this should be a float. I think, yes. So let's just print this thing for now. Okay. Yeah. And so now we just have to make our factory. So we're going to say factory here, or brewery, sorry, is our beer bottle brewery with num items of 4,000 or something, right? And so I think if this works the way I expect it to, what we should see is that at the first when the bar is all the way at the bottom, since we've set the scroll bar to be 25% of all items, we should see numbers 0 to 3000 as we move the scroll bar around. So it says 0 right now, and we go to the bottom, it's 3000, right? So this is really good. It's working exactly the way I expect, which is very good. Very good. Okay, so now what we want to do is we need to start doing layout, right? So here, so we have to I think store the widgets locally, or is it like up to we have to decide, is it up to the brewery to store his active widgets? I think no. Maybe. So maybe it's like purge, like destroy widget is one of the things that you might want to do, right? And he's just going to give him the index, right? Because he knows if things are on screen or off screen. And he can also create widget. And this is going to return, I guess, a GUI widget. Maybe? Unsure. So this guy is just going to create our, like, label widget, right? So this guy needs to hold, like, a factory in him. He probably also has, like, an allocator in here. Probably. I'm not really sure. Because these widgets, our widgets currently don't have, like, D in it. So we're going to store the concrete versions of this widget, I think, is what we have to do. We have to store something concrete, and then... Yes, because whatever widget that we have, he's going to be associated with some text, right? So if we were just to do factory here is a GUI... I think it's in factory, widget factory. And if we were to just kind of blindly go like factory, make label, right? And we say like, hello. The problem here is that like this make label gives us this generic thing and we can't like change it anymore, right? So we actually have no way of freeing the widget that this created because of the fact that we kind of expect to leak everywhere. So we might want to make either we add like a D in it to that widget, or we kind of like, or we can expose this thing. We could do some sort of like make label concrete thing. That's an option, right? So we kind of like give us a way to access this structure directly. But in reality, like this label class is not that fancy. I would think that like anything that we're really doing to do this, like, is gonna be a custom widget. Probably. I guess not. Yeah, okay. So I think we want like a label pool. And this is going to hold labels. Like, and we know what type this is going to be. Like all of our, we have like a concrete type here. It's label that is wrapped with a string. Maybe. No, this is going to be, we're going to have like a custom retriever here. Because we need to like hold, if we were to allocate these strings, I guess we can do that. Yeah, we can do that. Fine. That's fine. So here we have probably, we're going to use the allocator here, and we're going to use a general purpose allocator, which we typically don't do that much of, but I think that that'll be easier for now. It would be nice to arena this, but because like random strings are going to be coming in and out, it's kind of hard to like nuke the whole arena at once. So I guess this guy is like this. And here, hold on, when this label, does this label store? He stores the text in here. Yeah, okay. There's a way to do this. There's a way to do this. So here we have print beers or something. We have like somewhere we were already allocating this stuff, right? It was here. So can we do somewhere like alloc beer string? And we will do this on some allocator. Okay, perfect. Perfect. And here, I guess this is with I, or numbeer is here. Okay. And here we just return buff. Easy. Okay. So now we can say we have our general purpose allocator who alloc beer string with index and our general purpose allocator. Perfect. And then we need to expose this label as an actual like thing that holds what? It's just text retriever. Like this. And so this make label is going to be concrete, which returns a pointer to one of these guys. Which is what? Label of type of text retriever. And then we have make label is going to call make label concrete. And this returns kind of the generic actions that we kind of keep the way everything worked before. So this is a widget action. And so here we're gonna be like const concrete is make label concrete with all this shit. Make label concrete does not need this action. That is unused. I think. It's something like this. I don't know yet. I don't know. And then we have this all works like this. I think we're chilling. And so now we should be able to make label concrete here. That pulls the concrete version here. Bing, bang, boom. And so now we fuck this up. Alloc here. This guy needs to do something with this thing. So now we can call self factory make label concrete, right? With hello. And I think we might need to cast this here because I think that this is not going to be coerced nicely. But this is label. And we only do this if we don't have one in the label pool already. Yeah, so this needs to be like a list of you know, labels that we have available to us, probably. So we're like, here, let me pop a widget off this thing. Or else make one. Perfect. And these are pointers, actually. Pretty sure. Cool. And then this guy probably wants a as widget now. Yeah, that seems reasonable. Who needs to say which action he's associated with, because he doesn't store that thing inside him. Easy. So now this guy can return concrete as widget with action. And then this just kind of lives in here now. And we need self here. Sure. That feels like it all works. So now here we can return label as widget like this, which should work, but he doesn't seem to like that. We'll figure that out. And then also when we make this thing, this guy, this is the beer string that goes in here. And we actually maybe give him a null string here, or undefined even, and then we can kind of assign in here is what we're trying to do. Yeah. We're getting somewhere. So this can fail, and we assign the text now. Label.text retriever is equal to label, or beer string. And then I hope that this is something we're allowed to do. So on update, he checks if the wrap width has changed, or if his existing text has changed. Right, perfect. We are so fucking chilling right now. He doesn't seem to think that this as widget function exists, but maybe he didn't save? I don't know. Okay, so if we destroy a widget, interesting. So we actually have returned the generic version to him, but we need to hold the concrete version of this thing. Okay. I guess we know, though, that the widget's concrete type, we kind of know what that is, right? He probably is going to tell us which index it is, because maybe we have like rows of non-uniform widget type in theory. So we should be able to know which index it is. We're going to discard that, but we should say like index could be used to deduce the type of the widget. Could be. And then he will give us the widget back. I think that makes sense. Because then now we can say label pool append concrete, and we need to get the concrete type back. So we say concrete is a whatever the fuck this thing is. GUI label of strings is a pointer cast, a line cast of widget context. Okay, we're getting somewhere. And we put that in our pool. Fucking easy, and then we also free the string. So we say concrete text retriever is undefined, and we also free the existing text. Okay, that looks like it might work. So for now, can we, in layout of the scrollable list, we now have to start querying, right? So, while something, who knows what yet, we I don't know. Check if we have that widget, probably. So we need to store maybe like last top, last range, maybe last widget start and last widget end, right? And we can have some sort of like has, like has widget. I guess we do need to store these, right? We need to store the widgets. So we can just say first widget index, maybe? Yeah, that seems reasonable. And we can kind of go like for first widget to the truncated version of the top index. So this is kind of floating point. Is int from float of this. Okay. And we go like, for every item that is lower than this, we like return this back. So we have like, do we have like ordered remove? We only have swap remove. That sucks. That's a problem. That's annoying. That's annoying. We could just write it. We probably actually want to like remove a chunk, right? Remove items. Ordered remove items. Or something like this. Which is gonna go like from first widget index, no. 0 to top index minus this, right? So this is all of the widgets that are off the screen. And I think that we kind of only want to do that after we iterate them, right? So order remove many if you want to keep in line with the UI list. Nice, 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 nice. That is, I was hoping that somebody would tell me I'm an idiot there. Okay, so for this, we want to take active widgets at this index, right? And we want to give this back to the factory. That's kind of what we were saying before. So this has like a destroy widget. Yeah, destroy widget. And this, we give them the widget and the index that this is associated with. Other way around. Okay. Then we remove everything in that spot. Beautiful. Then what? Then we set first widget index to this. Okay. And then we start iterating. Yeah, so we have like, now we have like active widget iterator, probably. Active widget iterator. Okay. Not sure where this is going yet, but this feels right. And then we go like, this is like an infinite loop. And by infinite, I mean like, we either run out of widgets or give up. So I guess it's more like while, I guess it's like, for, I don't know, this is related in some way. If I is greater than or equal to the like number of items, then we break out of this thing. Yeah. So we query this one time because we don't have any guarantee that this isn't an expensive operation. We convert this to a float to figure out how where we are relative to the scroll area. We then keep going until we find we run out of items or something else. Okay, so we check our active widgets first. So if we have one, we update it. It's probably like, if we may have it, or if we don't have it, then that means that we need to get it from somewhere. So factory, right? We're just like, here, hit me with one of these. And then we call widget update. So it's probably something like this. Unsure. You're assuming that you're scrolling down, right? You also need to remove widgets after last index. Yeah. We'll get there. Here we can do. I guess we need to do this, or else active widgets append. Ooh, this is sketchy. new widgets is a new list of widgets. I don't know. And I think that we work off a scratch allocator. Right? We kind of say, okay, so we're going to do some shit here. And we're gonna reclaim this memory later. And in here, we are going to use this, so to stash a bunch of stuff. And we have some guesses at the size, right? So the kind of typical size here is what? Like, I think that we can probably make some better guesses than this, but like, surely we're not going to have more than like 10,000 widgets in here. Edit, update guess. I'm not really sure about this, but like, those seem like reasonable ranges to me, right? Maybe like, because like, you know, on a window, how many rows are you ever going to have of something that's like sane, right? 100 would be, I think, a lot, right? Like, how many rows of text can you even see on a screen at once, right? So I'm going to have to think about this a lot more, but this feels reasonable to me. And then we can say, as we are iterating and we create these things, new widget is this, and we do a new widgets append the new widget. Beautiful. Okay. We probably need to catch here if we run out of space, and we should restore the other one, right? We should like return it. If we fail, yeah. I think that's right. I think that's right. If this fails, are we chill? Yeah, because we've already handled the removal, and so we're kind of chilling there. So then we update that widget, and we probably want to do something like get its size. So I think that here we probably, I think we just do this. We start with the container size, and we use that available size here. And every iteration, we say available size height subtracts the widget's size. So widget size is widget get size, and we subtract the widget size height here. Beautiful. Cool. And then what? Like, if available size height, so this is equal to 0, we must have laid everything out, right? So this is one case is we've run out of space. There's literally nothing to lay out, so we bitch the fuck out of there. If we have run out of items to render, we also rip out of there. We might argue that this shouldn't happen, but I think this will happen if there's only a couple items on the screen. Is there any other exit case here? I think no. I think those are the two exit conditions. 10k of lines of text is a sane guess. You'll run into usability issues long before the system starts failing. I think that's reasonable. Yeah, I agree. But I do want to I just want to like think a little bit harder about it, so I'm putting this here. So then once we're done all this, we've kind of put these new widgets in a spot. So we kind of want to append each of these widgets to the existing widget list. Which looks like this guy wants to be tried for this to work. And I guess like there's a chance that we run out of like that this can fail, right? Because we can go like while new widget iterator next. I guess it's like active widgets append. I think it's like this. And then if this fails, what do we do? I think that this widget just dies. So I think we can just do like factory destroy widget. I think this works because on render, we'll just lose the state associated with that thing, and that's fine. Sure. Sure. That seems reasonable. By the way, I think in this destroy widget thing, I think that we are missing we probably need to like remove GPU objects for layout, right? Like this has done some sort of like pre-rendering of stuff into a texture that needs to be cleaned up, but we're not doing that right now. It's okay. All right. We rip our size to be the container size. I think that's fine. And now we update the ratio. So we kind of know how many items are in there, right? We have the scroll bar. We have our active widgets now. And active len f is this. And we have the num items f. So we kind of know how big the scroll bar should be. It's how many things we managed to lay out. Yeah. That seems kind of reasonable. I'm sure that there's a reason that this is fucking busted. But let's just rip it and see. I'm worried a little bit about immediately ooming. So let's just double check what is the sysrq key for killer. Sysrqf. Alt sysrqf, right? I'm pretty sure. All right. Let's open top as well so that we... Okay, well... I think that we didn't finish implementing all the functions yet. As well. Did we lose has widget? Why did we... Well, okay. Let's... Unbounded for loop. Fine. Fine. Something like this. Missing factory. So here I think we need like a GUI state, make a new factory with a new Alec. So we're gonna call this like beer Alec is going to be a sub guy of the GUI Alec. So that later if we decide to like just nuke this whole thing, it's easy. So that's kind of where this comes from. And then, is this guy chill? Num items 4,000. And then label pool, we need to initialize with, we know that the maximum amount of widgets that we could ever run out of is like 4,000, but that's already insane, right? So this should be, so he's gonna use the beer Alec. Keep arena for the initial allocation of this thing. He's going to use the expansion allocator for the expansions. His typical size, we'll say 8 maybe. And his max size, it's like, we know that this shouldn't get bigger than like 100. 100 would be a lot, I think. And maybe that's fine. He's mad. What's he mad about? Missing field scratch. So true, dude. All right, hit me with the scratch allocator. allocators, scratch, linear. All right. First widget index is going to start at 0, probably, and then active widgets. Do we have guesses here? I guess we kind of use these same guesses, probably. Typical active widgets, and then max active widgets. And then that means that this guess down here actually can be a little bit cleverer. Right? Because we can kind of say that this is like the existing active widgets. Right? We kind of know that we can't get more than yeah, we can't get more than this. And then that means that like technically there's this catch destroy down here probably doesn't happen because we've already validated that we won't run out of room. But I guess technically the allocations below can still fail. And then this guy we do the same shit, right? So we have try init with scrollable list, factory, typical, max, and then we're using the arena, and do we have an expansion? Yeah, we do. What is this? This is alloc heap expansion. Boom. Boom! Okay. Try here. And then I guess this we should actually do like a this guy shouldn't fail, I think. And if we fail, we will just log an error. Dropping widget. That's fine. No room in pool. Dropping widget. All right, what else is going on? Ordered remove many. We need to implement that. All right, so we probably have like something ordered remove many. Who takes in self and a start index and index and this is probably this is a mutable thing. Seems reasonable. And this container is intentionally supposed to be like a vector, but instead of storing all of the memory contiguously, like this, it stores them in kind of like ordered chunks. The idea being that our allocators typically, we try not to use allocators that free individual items. Instead, we use allocators that can allocate like a page at a time. And so what happens here is we allocate like one page and we allocate like another page and then allocate like another page or like whatever, or like maybe we double the size of the allocation every time. And we want like our pointers to be stable. We want this thing to be like arena friendly, right? So instead of, we just leave the old items where they were and kind of have new slices just for convenience. So our order remove many must go, there's some impl class here, this guy, and on him, he's going to do the actual work. So where's our thing? Hello, ordered remove many. Okay. So on this impl guy, we just huck this shit at the bottom, and I think all we need to do here is get an iterator for the beginning to end. I don't know. And like copy back, right? So like we want iter from, do we have like the do we have ways to get iter here? Iter from. Yeah, we have self iter from. No, that's on impl const. I see. Can we, do we ever, like, we have impl const and impl. I don't know why we did this, but can I make an impl const from an impl? Surely. So this is my impl, has this stuff. Oh, it's because sometimes we want sometimes the length is modified and sometimes it's not, and for some reason that's relevant. All right. I don't know why we did this that way, but fuck it. I'm sure there was a reason. So I'm just gonna hit a little as const here. And we're literally just gonna do this. I don't know why we did this. Pretty sure there's an impl const already. There was an impl const on like the big book, on like the top level guy. Oh no, yeah, there's one here. Oh yeah, it was right next to that one. God damn it. It was literally right next to the code I was looking at. That's funny. Okay, so we have this guy, and we have impl iter, and we can do iter from start indexed, and like dest iterator, and we have source ID, like source iterator, and we probably do like while true, we do a little copy, right? So we have like D is dest iterator next, source is source iterator next. If either of these guys are, if this, I guess dest iter should be a crash, right? This is a bug if they pass in an end index that doesn't work. But if we have a source index that doesn't work, that means that we've hit the end, which is fine. Then we do like this. And then we just have to do a resize, right? Which surely is a thing that we do. Do we call it truncate or what? Shrink. So we have like copied elms. And then we have minus copied elms, probably. And this guy's in charge of freeing stuff if possible. Seems reasonable to me. Okay. Unable to resolve comp time value here. That's interesting. What is he pissed about? Whoa. Okay. Comp time only type. Make label concrete function return error type blah 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 blah. Make label concrete here. Is it because like text? Oh, this needs to be as one of these probably. Okay, we're getting closer. Label has no. This needs to be a capital C. Do we build? No. Okay, we're getting closer. We do need to return something here, huh? Okay. This guy is mad because this returns a pointer. And this is mad because beer string cannot fail. Label as widget needs to say I am a widget related to GUI action. Beautiful. This guy needs to have a block here that is broken. with the new widget that we made. So true. Incompatible types. So this is fuck. This guy needs to be dereferenced. So how do I do this? Can I make these types match? This just needs to be a function, right? This just gets pulled out into a function. So this lives like in here somewhere. I don't know. New widget. Next widget or new. Iterator. I totally wasn't nerd sniped a second time. Hell yeah, dude. Wait, you missed the and though. The and was the hard part. You gotta, if we to nerd snipe you a third time, if you get the and in there, you're a god. But yeah, this looks like, is this the same as we have? Like how similar is this? I like aliens. I think what you have is similar. For 1 to 7. Oh, this is order of magnitude? Yeah, and then you recurse. Very nice. Very nice. Okay, next widget new. We have an iterator, which I don't want to know the type of right now. And we have the factory, which is of type factory. And this will return a GUI widget. And okay. If it next value, we return value.star, then all of this stuff comes down like this. We need new widgets, which I also don't want to think about the type of right now. So we just fuck that. And we also need index, I guess. Okay, there we go. So now up here, wherever the fuck we were, we can do next widget or new with all this stuff. So we have our active widget iterator. We got our we got our factory, and we got our new widgets, and then I'm gonna throw on here a fix me. Remove these any types, idiot. This thing surely can fail. Very nice. Okay, update needs our delta time. All right. Oh my god, we build. All right. Does and only appear after 100? Not really, but kind of. It appears before the last 2-digit numbers. So it's like 1005 is valid. 1305 is valid. 1345 is valid. You know what I mean? That's where we started to get like really tripped up. Okay, let's see. Okay, we might here. Alt sysrec F. If that happens. Okay, good. Something instantly crashed, which is better than that. Okay, so this ordered remove many is too many. Interesting. Because I guess it's 0, right? So we're trying to immediately get out, so maybe if we do it the other way, that kind of solves that problem. Okay. Are we ooming? Lots of rows is 1.1%, 1.2% memory, 1.3. So we are slowly growing, which is a little scary. We are slowly growing. Which is not good. Which is not good. Who would this be? It cannot be anything on the scratch allocator. It's gotta be the factory. Oh, but maybe this is... Okay, let's throw some logs in here. Because, like, what we should see is that this create widget is very stable, right? We should be seeing that this is only called every once in a while. Creating widget this number. And then we should say destroying widget. Yeah, right? So, obviously, we have a fucking problem here. He's spamming creating widget, even though like these things are already in the list, right? We put them in the list here. So maybe our ordered remove many is a bug here. Removing this many widgets. Like, what the fuck are we doing? Removing 0, okay. And then, oh, did we forget to remove the ones at the end too? Yeah, we need to fix me, remove widgets below, no longer needed. Okay. But we are spamming create widgets, which is interesting. Which means that, like, this active widget iterator can we log the size of this thing? Num active widgets. What the fuck is going on here? 0. He is never adding. So what the fuck is going on there? Are we not pushing into new widgets? New widgets append here. And then for each new widget, we should be appending that thing. It doesn't fit. Is it this? Appending to active widgets. What the fuck is going on here? Okay. So he thinks... Okay. So he thinks that there should be. Can we say it at the beginning here? New widget, or active widgets on update. Oh. Is my shrink call fucking stupid that we just added? Could be. Could be. So, yeah, active widget update 36. Then probably after removal, we're doing something brain dead. So this guy, is this the new size? Len is size. This feels right. While copied elms is less than end index minus start index. We are always going all the way to the end. Yeah, something like that. Yeah, let's go, baby. Okay. Now what's happening? So, okay. It looks like we're relatively stable. It doesn't look like we're seeing memory usage of our guy freak out. He's kind of stable here, right? We've got him at 253, 692 all the time, which is nice. Oops. Okay. When I scroll down, he's not happy. So what's going on there? He is trying to destroy widget. So he's looking at the stuff in text retriever in our factor thing, and he's going, uh-oh, no good. By the way, you can just limit memory usage with Cscope. Oh, hell yeah. Or systemd run. That seems really good. That sounds phenomenal. Because I should be doing that for sure. Okay, so it's in destroy here when he's trying to free this. That's interesting because we should have always created it with this, right? And there should be no scenario where we didn't put this guy in there. Is this a... What is this? This should be of type const u8 in here. So can we double check that? So text GUI text const u8, text retriever const u8. Yeah, so we should just be assigning this to what we saw. Does he say what the thing is? Freeing this guy. Okay. So for most of these, it's right. But at some point, we get undefined. So I imagine that's after we create and destroy a new widget, would be my guess, right? So can we have creating widget, destroying widget logs, right? So we see destroy 0, 1, 2, 3, 4, 5, and we create 36, 37, 38, 39, 40. Then when we get to just widget 12, we freak the fuck out. There doesn't seem to be anything special about 12. Can we... So this is stable address, greater than the allocator. We're not like making this on the scratch allocator or anything, right? Because this is on this beer allocator. Interesting. Let's do this. We'll say creating Bridget here, and we'll write down what his address is. So we'll say we have the label is at this address, and the text is at this address. And we can figure out if we're doing something really fucking stupid. My limit is also 12 beers, thank you. Okay, this is destroying widget, which has the pointer of concrete and the beer string of concrete text retriever. And then we need to remove that like active widgets on update log. All right. So we create these things and they are getting like, you know, somewhat sequential addresses. When we destroy 12, we have 1 DO. Okay, so it looks to me like the destroying widgets are getting the wrong index. 0 is 54. 5400. Okay. Okay. Then, what about like 6? 1 DO? 1 DO, interesting. But then 12 is 801 DO again, right? And that's the bug, is that like it thinks that 6 and 12 are the same thing. So when we assign undefined here, it's because we already unassigned it on 6. Okay, but when we made 12 up here, it's 6,000. So it must be like the tracking of which widgets that we are returning. We must not be tracking it correctly in our list type. It must be, right? So when we call destroy widget, we are giving him the wrong one. So that would probably be here, right? New widget iterator. Oh no, that would only be on it doesn't fit. So that's not the one. That would be in the typical case. So from here to here. Okay. So we assign the first widget here. We remove from 0 to... This should be a saturating cell, by the way. So we find where the top of our screen is looking at the scroll bar. And this is the first thing we had. So we subtract those things, and if they are the same, we get 0. If the new place is like 1 above, we should remove the first 1. Or 1 below. If it's 2 below, we should remove the first 2. Okay. So let's do a little log here. New position is this. Old position was this. Okay. Top index and ratio, and the first widget index. It must be that this tracking is wrong. So new position of 13. Old position of 0. So we destroy widgets 0 through 12, which is correct. And then we have to create all of the new widgets here, which also seems correct. Then we have new position 26, old position 13. And when we get to 26, we're mad. Okay. So 13 OE8. Ah, fuck. If top index ratio is not equal to first widget index, we'll do this. I think that makes things a little bit easier. And we'll probably put this log above because that's more clear. Okay. Yeah, so we jump up from 33. Okay, so on the first set, we destroy 0, 0. Okay, hold on. So we create the first interesting number here is 13, right? So 13 should have address OE8, right? Which we do destroy here at 13, okay? Then we get to 26, and that's where it's bugged. So let's just double check here that these numbers are correct up until that point, right? So like the 25 should be BC8, right? So when we created 25, BC8. And so it's literally just 26 that's busted. Am I assigning the wrong thing when I move them backwards? Hold. Yeah, it's weird that just like one of these is wrong. I wonder if like 25 is an interesting number in some way. It might be like our container is fucked up there. I would like to double check ordered remove many here. Is it possible? Can we just do like a std debug assert that the type of a D is a pointer to T? Am I stupid? Oh. Okay, so we are copying pointers to pointers here, which is good. Let's print the active widgets after this. Maybe. After, if these are not equal, let's just print the whole set of active widgets. Okay. I think using and in numbers such as 101 is subjective. I'm leaving it out. I couldn't figure out how to easily do it and gave up. Yep. We did the same thing. We also tried and then gave up. What is he pissed about? Oh, it's a widget. I see. Okay, so when we destroy these things, we should see that we deleted anything. So we delete 540 up to 00E8, right? So we see 00540 to 00E8, and she say 1DO, 2B8, right? 1DO, 2B8, all the way down to 3000, which should be down here. So that's all correct, it feels like. It does feel like that. Destroying widgets. So this is... new pause 6. So then we have 1DO, 2B8, 3AO. And this should go all the way to 658. Oh, this is 1DO again. Wait, this is wrong. This is wrong. This is repeating. Okay. So that's interesting. So this is after the first ordered remove. We were ordered remove 6, and we copied back. Oh, I'm an idiot. That's why. I'm a fucking dumb idiot. When we're ordering remove, we have to iterate the whole fucking list when we're copying backwards, not just the first 6. Am I fucking stupid and dumb and stupid? Am I a stupid, dumb, stupid, and stupid? This is literally just copy until we get to the fucking end. I'm a dumbass. I'm a dumbass. Okay, that's better. Although we are spamming creating widget again, which is what we were trying to get out of here. Because this shrink is wrong. This should be shrinking from end however many things that we removed, right? So removed elms is end index minus start index, and then we need to shrink this to be the self len minus removed elms. There we go. And then we don't need to copy copied elms anymore. Because, yeah, there we go. Closer. If index is greater than equal to self.len, we're unreachable. At get impl. 686. Because we're trawling gets on values that don't exist anymore. Okay. We're getting closer. So where is this coming from? On widgets get I minus first index at 245. Okay. Yeah, true. If, so this is the widget index, active index. And we should not be getting this. If active index is greater than or equal to the active widgets len, break. I guess we need to do. Then this is gonna have the same problem, right? Where we're going out of range here. So we should say to remove top or something is top index ratio sub saturating the first widget index, and then the minimum of this and the length of the array. I think that seems kind of reasonable. And then we can go for 0 to remove top. This is the active index, which we can use here. And then we destroy this with this plus to remove top here. Cool. Then this is to remove top here. Beautiful. Okay, does that work? Looking good, looking good. Okay, we're not actually rendering anything though. So can we actually do that now? Now that we have them, it should be easy to be like, first we need the like widget bounds, which by the way, we need to clamp the width to avoid the scroll bar on update, but we'll handle that later. So this is widget area bounds or something. And I guess we might actually need to store where they are relative to our widget in this active widget thing, right? Because like the layout part of this is kind of trying to choose where they belong, right? As we like shrink the available size. So I think when we insert this into the active widget list, we kind of need to stash its position. So we have like the widget here, right? And then we also have the like rel pause or something, which will be GUI pixel. Is there like an offset? What do we do in layout? In like typical layout, this guy must store something. Layout item stores the bounds of the item. Okay, we can do that. We can do that. Fuck it. I think that might be storing a little bit too much. You know, this could be like technically the size should be stable, so we might not need this, but like whatever. Okay, so now we just go and we render it. So we go for, I guess we have like our iterator is our active items. And while we iterate, we have some active widget. And I guess we literally just probably render it, right? We probably have like some like active widget render with its widget bounds. So we have its bounds here. And the window bounds we say are the window bounds. Beautiful. Wait, easy. This needs to be active widget now. And then that means that on update, he's going to be pissed in some way. Right? He's going to be like, this doesn't fucking work. Right? So this is like this. Easy. Widget. Widget dot context. Okay. This guy is going to be mad somewhere because... Wait, what is this mad about? He expected a GUI action. This would be... What is this doing? When do we use this? When we're calling update. So I think that this actually wants the active item. I think. Not sure. Feels like it. So then... Oh, we might be able to get away with like not a pointer here. Not sure yet. This we append here. It's like widget is new widget. No, because we want to modify it. We do want to modify it, right? So we say bounds is undefined, right? Or maybe they're default bounds, just for less confusion. And then we return new widgets at new widgets len -1. Yes. Yes, 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 yes. Something like that. So now this guy is like, yo, I can call widget update. And I will assign the new bounds to this thing to widget bounds. So, how do we do that? Top is available size height. Container size height minus this is probably right because like the size is shrinking. So at the beginning this should be 0, and then as we use space we kind of move down. Bottom is top plus the size. Bottom is top minus or plus widget size height. That seems reasonable. Then the left is probably just 0. I think we're just left aligning this no matter what. And then this is widget size width or something. That seems reasonable. And then these bounds are relative, right? So we can't just do this. We need to do like widget bounds offset. I think we want like widget bounds is render bounds is going to be the active widget bounds offset by the widget bounds top, like on our top left. Probably. It's like probably something like this. That sounds right. There's like a chance. No field name widget here because next widget or new took in a scratch thing, and this is active widget now. Bounds is missing. We literally just left, right, bottom. Just fuck my shit up. Oops, wrong button. All right. This guy, destroy widget, is mad because we need widget.widget. It's a widget. And let's go! Wait. Scrolling down works. Scrolling up is broken. Because we didn't clear the widgets. We need to remove widgets below no longer needed. So we do an ordered remove for everything from the top, but we need the bottom as well. Yeah. I think. So Hum 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 hum. Yeah, we must be just leaving widgets on the bottom. I think that it feels wrong to me the way it's failing, but it must not be. Okay. So I guess. Sorry, I'm just thinking. I have to. My brain's not getting there. So we have these widgets stored. We scroll up, which means that the widgets that used to be here, we need to chop some of these off, right? But like, how much of them do we need to chop off? Depends on how many items that we needed to lay out, right? So here we have I here that tells us how many items that we laid out. And so I guess it's like The new widget stuff is a problem as well, because it depends on if we're going up or down, right? The new widgets, we need to either prepend them to the list or append them to the list depending, right? Yeah. Yeah. So it's like that. So that, yeah, it's two bugs here. It's two bugs. Uh, do we have an insert at? No. That's annoying. That's annoying. We do not seem to have an insert. Okay. Fuck it. LMT or something. So what happens here? We like look at, we kind of move everything forwards. So we go we have some iterator. We have our source iterator is, it's going to be very similar here, right? We have our destination is iter from index plus 1. Source is index. We do the same assign here. We know that the destination will break first. The source should always exist. I guess like if we're trying to insert at 0, then we may or may not fall over, right? Like if index is equal to 0 and self-len is equal to 0, I feel like that's a special case. Right? I feel like that. But not sure yet. So we need to push something first, right? Yeah. So we append an unreachable. So then our source iterator is the index that we're putting on. Destination iterator is plus 1. The source has to exist. If the destination exists, we copy from the source to dest. Beautiful. You want to go from back to front? So true. Do I have a backwards iter? I don't. Fuck. Fix me. Impl backwards iter. Yeah, you're right. So dest idx is len -1 len -1 source iterator. We probably saturating sub here. So this is -2. So if the length is 1 in the 0 case, I think that this kind of all is clean. Then we go while source index is greater than or equal to index. While it's greater than index, greater than equal to. We do get pointer dest idx is equal to get pointer source idx. This is expensive because it has to do a bunch of like extra divisions to figure out slices and stuff every time, which is annoying. One of these is inferable. Okay. I think that's right. And then we can say get pointer at index is equal to lm. And I don't think this is a special case anymore. Because source index, if in the case where index is 0 and the length is 0, we will get source index, len will become 1, we'll try to subtract 2, it'll become 0, and then what this will be greater than or equal to 0, and we'll try to do it once, which is wrong. Is this greater than? No, it has to be greater than or equal to, which means that we do have to special case 0. I feel like I'm missing something. Could start at len and then do a -1. Yeah, you could. Yeah, I'm missing a case here. So I pen unreachable. So I have like 0, 1, 2. Then I have 0, 1, 2 unreachable. So if I am inserting at index 1, my source index start as 2. I copy 2 to 3. Then I copy 1 to 2. And my exit case is when it becomes 0, I stop copying. Okay? What about in the case where I am empty? I append unreachable. I guess it's like if dest index is greater than or equal to self-len. I think that you just have to do this. But this is just a special case, so yeah, I'm not sure. Fix me. This surely can be represented better. I feel like this is wrong. This is like stupid. Because I think this is like just one special case. Like maybe one special case check outside the loop. But I think this is right then. I think. Which is really all that's important. This is really not really I don't need to do this well right now. And then we should do a fix me, add these to unmanaged. Okay. Cool. So did I do the insert part of this already? No. Okay. So if we're going backwards, new elem side. I don't know. Is equal to I guess this kind of goes up at the top somewhere before we assign the new first widget indexed. Top index ratio is, so if the scroll bar is greater than this, it's bottom, else top, probably. And then depending on new elem side, we're gonna do something different here. I don't know what yet. If it's top, if it's bottom, we did whatever the fuck we were doing before. Thanks, everyone. Later. Right? It's this. But otherwise, we are inserting the widget at 0. All right? So that kind of fixes half the problem. And then this should work, but just be wasteful when we scroll up. Assuming that we do this all correctly. Error unit is ignored. Fine. Fuck. Self-append unreachable is getting mad because panic reached unreachable code. Oh, fuck, not unreachable, undefined. I'm a dumbass. I'm a dumbass. Wrong keyword, baby. Now what? Impl C get pointer. Expected type this, found that. Because I need to dereference that thing. So true. Where is that happening? That is in 626. Runtime segment says 626. No. 626, not 262. He's pissed off because no field named get pointer in RSL impl. Fine. Now he's pissed because if index is greater than or equal to self-len, unreachable at get impl at get pointer at index. Are you allowed to pass undefined to a function in Zig? I know it's undefined behavior in C. I'm pretty sure. Pretty sure. Okay, so now he's mad because index is out of bounds here, which is confusing because we're only ever passing 0 here, and we appended 0 here. Right? Std debug print index. Oh, because the length has changed. That's so funny. I'm pretty sure. No? Okay, wait, that's not it. Yeah, that's confusing. This is stupid, by the way. Ew. Okay, and this is at 626 again. Oh, I accidentally removed this deref here. Okay, now he's mad at no function named self. I'm so fucking high. I could have sworn I already made all these changes. Now he's mad because it's still unreachable. So can we still debug print what are we trying to fucking do here? It should be len should be 1 and or index should be 0 or something like that. One, 0. Wait, then what's the problem? Oh, it's on get pointer dest. Oh. This is even dumber. Ew, 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 ew. Okay. Integer overflow here at 629. Okay, because we are at 0. True. If source index equals 0, break. This is all nasty, by the way. Okay. Are we cool on memory usage? Yeah. Okay, scrolling up is still broken. Scrolling up is still broken. You only had once at the top. Oh yeah, true. True. Still gross, but you're right. You're right. You're right that this is fine, but it's okay. I guess it must be that we need to, I guess before we... So as we are scrolling up, we... Oh, I guess it's like to remove bottom. We just do the same thing. But just the other way around. Yeah, easy. We just invert it. No, because we don't know how to remove at the bottom until we've calculated the sizes of everything. Fuck. Okay. So we have new bottom is I. Old bottom is needs to be calculated based off of the old first widget index plus equal or plus the number of widgets that we were stashing, I guess. That seems right. And so we do like for new bottom to old bottom. We do something. We do something. Which is gonna look a lot like this. If so, I think that we can assume that old bottom is greater than or equal to new bottom. I guess the content of the widgets could have changed, which could cause problems. And it should be old bottom to new bottom, probably. No, new bottom to old bottom. If new bottom is greater than or equal to less than old bottom, then we do this. And what the fuck are we doing? We're like, we do an ordered remove. Like this, right? We haven't adjusted this thing yet because we append here. So we're good. We're good. We're good. Yes. Okay. And so then we just do this destroy widget. Right? Right? Okay. Scroll down. Scrolling up is still fucking busted. I feel like scrolling up is never working the way I expect it to, even when we're not purging widgets, which I think is part of the problem. I'm expecting that as we scroll up, new widgets are getting inserted here. So can we skip this for a second, and can we check layout direction? So if the scroll position is changed, can we print out what the new thing is? Where do we calculate that? New LM side. New LM side is this. New LM side. And then we have to comment this out for a second. Fuck. Okay. So I scroll down. And it does say new LM side is top here. So that's interesting. You would think that if new elements are getting prepended here, that we would be seeing them. Right? Like, that, then we should be seeing this, right? So we should be saying, like, you know, old, do we have old length somewhere near? Yeah, I mean, container size. Like, we would assume that when we're scrolling up, that the container size is just growing. Right? So, like, as we scroll down, it kind of stays around 36. And then as we scroll up, it's also staying around 36. And that's confusing to me. That's confusing to me because we should be inserting new widgets here. Next widget or new? Oh, because we're fucking assuming that the active widgets are going that way. Fuck! So, we need to be able to, That's funny. That's funny. So we need to be able to iterate backwards, right? Is that true? No. This just needs to be iter from here of the uh top index from ratio or something. Something related to those two things. The first widget is 0. We're trying to iterate from 5 or something, or when we go up, we're trying to skip the first 5. Which means it's got to be this way, because we're going up, which means it's saturating sub this way. Still no. Still no. Hmm. What are we missing? What are those logs for? Do we have logs on creating? We do. Right? So he's not even trying to create widgets, which is interesting. If I'm reading these logs correctly, I just want to remove somewhere we're logging way too much. Somewhere in this fucking pile of fucking garbage ass crap. Here. Right, so when we scroll down, we see a bunch of like creating and destroying, and when we go up, nothing's getting created. So that's the problem, right? Which means that he's always getting the existing active widget. Maybe I have this backwards. Oh, wait. This needs to get assigned later. Okay, closer. At least something's happening. Do I have this backwards? I don't think so, but... Yeah, I think this way seemed more right. And then I guess we need to destroy the old widgets, which we got rid of the stuff for. Which I'm sure was not helping. That's crashing now. Okay, we're still doing something wrong. We are still doing something wrong. So, for I here, he is calling next widget with I, and can we remove this iterator? That might just make things simpler. So at this point, first widget IDX is still what it was before, actually. Well, so we have removed everything from 0. Okay, no, so here the first widget index, after we remove all the ones from the front, does seem correct to me. Right, because here we have removed everything from the top, so the top matches where the top is on the scroll bar now. So this is totally valid after this order removed any for this to be like this. Then why... Which means that the active widget iterator should just be like an iterator. because the first widget here is in agreement with the top of the scroll bar. Okay. So then, does that mean this ordered remove isn't working? It's because we're not removing. Wait, no, I'm a dumbass again. I need to draw it out again. Okay, so we have items like this. When we scroll down, the new window is here. We delete these items. Great. When we scroll up, the window goes like this. And we are missing elements up here. That's the problem. Yes. So we need to calculate, I guess we need to inject elements here while it doesn't work. So this new next widget or new needs to keep track of like the first index. Yes. And if I is less than first index, I guess it's like if I is greater than or equal to first index, then we can do this. But we can't normally. So now first index is self first widget index, and that feels a little better. Fuck. So create, well, oh, that felt like it was going to be it. So we're still seeing no create widget spam, right? So by this point, we have tried. We have our I position starts at first widget. Oh, this needs to be min. No, this has to start at the first widget index, which is not. I see. This first widget index has to just be updated later. Still no? Why? I feel like I'm getting confused again. I think this does have to get updated later, and then I guess I needs to start the minimum of this and something else. Okay. Yes. Oh, we're getting closer. We're getting closer. We're just not deleting things now that we should be. But at least when we scroll up, something is happening. Wait, we're getting so close. Okay, now can we fucking delete the old stuff? So old bottom was the widget plus active widgets len before removal. Right? Before removal. Then the new bottom is just whatever our I position is. From new bottom to old bottom, we remove stuff and we destroy widgets. Crash. There's probably like an off by one in here somewhere. Probably. So this is at 326. Widgets get active index. Because this is in widget index space, which is obviously wrong. This is the I. So active index. Oh, fuck me. Oh my god. Okay, so new bottom needs to be in the correct space. Ow. Ow. So we... Can we do it in like size space? don't think so. I think doing a new bottom to old bottom makes sense in item space, which is going to be like 3000 to 3005. And we just need to figure out where... I guess it's like the last n elements is how many we're removing, right? So it's like to remove is old bottom minus new bottom. We kind of have like len is like old len. Like new len, I guess, is the old len minus how many items we're trying to remove, right? And then this is just a shrink, right? And then this get, it's gonna be like 0 to 2 remove. We have index or like back index is gonna be like get me self-active widgets len minus the back index, something like this. This is really nasty. And what widget is this that we're removing? It's like old bottom minus back index or something like that. Yeah. Maybe -1 here. Unsure if off by 1. Something like that. Oopsies. Fuck. Close. It feels like we're off by 1. Is this new len even used? Yeah, it is. Yeah, we're missing. This is a -1 here that there shouldn't be. Probably this one. Nope. For 0 to remove, new len is the old len minus to remove. Maybe there's like a +1 here that needs to happen. That feels right. But if I scroll up too quickly, we crash because we're integer overflowing here. So why is that happening? To remove is like it's like the distance between these has grown, but the number of widgets in the list has not grown with it because maybe because we haven't inserted yet. Maybe this has to happen after insert. Still, no. I don't really understand how that can happen. Right? Because, like, we have collected this many elements. I guess technically we removed some here. We technically removed some here, which could shrink the length of the array. Yeah, I'm not sure. I don't have a good answer, but if we just guard this is the classic, like, don't fucking do that. Yeah, so you can tell when I scroll all the way back to the top, we're not getting back to the top. Right? So it's not really working exactly the way we expect. Yeah. So there's a bug there somewhere. Somewhere. Fuck. Dude, I mean, this is kind of the problem with writing just like this prototype code like this, is like, it's a hot trash, right? And it's so hard to debug now that we've kind of like stacked all this stuff on top of each other. I will say that we're close though, right? Just for the, for the title, we can in fact probably put a billion in here without any major problems. Right? Like, we do get to, hold on, we scroll too far. 998,333,314 bottles of beer on the wall, and we can go scroll all the way back to the top and get to like 35, right? So at the very least, the concept here is working, but the implementation is busted. But we're close, and then the resize can like work as well, which is kind of nice. I would like to go farther here, right? But unfortunately, it's 420 already. Blaze it, bless up, something. I don't know, man. But I think we have to call it here, or because we're running over time. I think that there's probably just some indexing bugs there, right? That we have to fix. And I will do that either tomorrow in happy hour or off stream. Not sure, but we got somewhere close. The concept is working. Thanks for watching, guys. Apologies we didn't make it. Sometimes we don't get there. If you like what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It's 4:20 now. So anywhere between 4 hours ago and now if you're watching live. Some stuff goes up on the YouTube. This will. Some stuff does not. It basically depends on if I think it's like titleable and thumbnailable. If you want the VODs for the stuff that we don't post, those go on Patreon, YouTube members, or Twitch VODs. If you pay in the appropriate spot, you get to, help the stream continue, as well as get access to the stuff that isn't always posted. I think that's it. Thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid.